Hi, in this video we will discuss about reference types, which is a topic that comes under variables. And under variables, we would have seen what a variable is. A quick recap. A variable is basically a container that holds the data throughout the execution of the program. And the variable's data value could change throughout the execution of the program based on how someone has done their programming logic. Each variable has a data type which defines the kind of data it can store. For example, we would have seen primitive data types, which has like 8 types in it, which are primitive. And why they were called primitive is they hold the values in them, and those values are directly held in the memory. So those types have their values directly in the memory. That is one of the first distinctive trait for a data type to be a primitive. For example, if you would have taken byte, short, int, long, float, double, char, boolean, all these things will have direct value stored in the memory. And all these things can have a default value, which could be 0 or false or 0.00 when it is going to be your float or yeah, it is going to be a float, it's going to be 0.00 to represent the decimal. And similarly for Boolean, it is going to be something like false. And when you see, I would have also explained the size of a primitive type, which is going to be like 4 byte, 2 byte, 8 byte. The size of the primitive has a fixed size. And beyond that, you will not be able to use the primitive types, like those sizes are going to be fixed. And how you pass the value is it is basically uses a method called pass by value. And memory area for a primitive data is going to be stack. And we would have seen the same example is the 8 types which we would have seen. So these are the characteristic for a variable to be primitive. The very reason to say the key features that qualifies to a primitive type is in this video, we will be seeing about reference type, which has no similarity to what we spoke for a primitive type. For example, when you wanted to have a say something that is not going to be fixed. For example, whenever you take your integer has some fixed size, but then you don't want to use something to be fixed. You want something that is going to be mm, varied based on the object that you are actually trying to program. So in that case, people will wanted to use reference type. And there are some reference types which is existing in Java that one can opt when they wanted to use a varying size data type. So let's see. Reference type in Java refers to objects that are instance of a class. So if you would have seen in the int, which is int small one, and the small letter integer, and if you would have seen a float, a long, a byte, and all those things, they are not a class. They are a primitive type. Whereas in case of reference type, all these types are basically a class type. So that is what has been given in this definition. Like unlike primitive types, reference type stores addresses in memory to the actual data. Since they refer to the objects that are instance of the class. So whenever you have a class, let's assume that a class is going to be a blueprint. So you have a blueprint. In order to access your blueprint, you need some objects. So you have a class, you have an object, and how would you refer those objects? So during the reference that are trying to connect your objects to the classes are called as your reference type, meaning your reference types are going to refer the addresses in the memory. If you the core difference is it is referring to the addresses in the memory, not the actual data. Whereas in the primitive type, you will be accessing the values directly. when you declare a reference type variable, you are creating a pointer to an object. So you have class, and you have class a blueprint with some methods, and it has some uh, data types also, or it could be even your custom types. So you have some class, a blueprint, and then you're creating an object. So when you're creating an object, you will have to use a reference type. So that is called as a reference type. So this is the overall idea for a data type to qualify as a reference type, meaning it should be referring the of the address of the type or address of the data, not the data directly. So there are 5 types that comes under reference type. One is class, second is arrays, third we have annotation, and fourth we have enumeration and interface. So what is class reference type? So classes are most common reference type. When you create a object of class, you're creating a reference of an creating the reference to the object in the memory. So basically, I think this is the very example I would have said to define even the reference type. So whenever you create a class, for example, creating methods and putting some functionality inside that method, and when you create an object for that class, right, you will not be directly nobody can actually directly access your class. So you will need a reference variable to create an object, and that reference variable is going to uh, refer to the address of the values and not the values directly. So it is going to be a reference to an object that is stored in the memory. And second type that you have for reference is array. An array is a reference type that stores multiple value of same type in a single variable. So for example, a class can have a method in it, a class can have a variable in it, or it can have a different blocks also in it. So all this different types of entities or complex. Let's start using the word like block. Let's say there are different blocks inside a class. All these things are going to be referred by the reference variable, which is called the class type reference variable. So array is similarly like a class, but to qualify it and call it as an array type references, it needs to store multiple value of same type in the single variable. And the size of an array is fixed upon creation. So this could be slightly same as a class, but when you say it as array, you will be already defining the size of the array that you are actually going to be creating. We'll see the practical application of what we are actually going through the theory part. And we also have interface. So interface is a reference type, which is also similar to class, that can only contain a abstract method, default method, static method, and final variables. So if you would have seen, the interface almost looks like class, but then it is not a class because to qualify as an interface, it has to contain like the methods that is mentioned here, like the abstract method, default, static, or final variable. A class implements an interface to inherit this behavior. So with this is whole new concept that will be explained in the um, principles of your OOPS, I can say, which is your object oriented programming, where we will talk about the features of Java 8 itself, uh, like what is an object, what is a class, and all those things. So when that topic comes, interface could be even more relatable and understandable. For now, let's just keep it as simple. This is going to be something like a class, but it is not a class. It is going to be using a class. So when that concept comes, then when you see a programs kind of mimicking the behavior of a class, but it is not having the variable as a class name, and it will have a variable, it will have the keyword called interface. So that time it is going to be a reference type as well. Meaning if you use an interface and you put a next word in, towards a keyword called interface, and then you create and put some abstract method, default method, static method, or final variable. This whole interface data type that we have created, right? So that is also going to be uh, referred with a reference object, not with some direct primitive type of data. So that is why interface is also here, like how the array is also here and class is also here. And the fourth what we have is called enumeration. Enumeration is a special reference type that defines a set of named constants. Enums are used to represent a group of related constant. So you have class, you have array, and you have interface. So in an array, what is the difference between array and the enum would be like, you're in an array, you can have a integer type. So if you'll have an array of size 5, all the 5 elements in that array is going to be of type integer only, and the size is also fixed. And when you talk about enum, your enum is going to be like, for example, let's say that I wanted to have a days of week. Now, days of week can be a string. Now, I wanted that string to be connected with some, let's say, if I say it is Monday, I want it to be 1. And if I want it to be Tuesday, I want it to be 2, Wednesday 3, and so on, like Sunday to be 7. So my enum is going to allow me to do my own definition of named constants, basically. Whereas in the array, I wouldn't be able to achieve that. So these are also like a kind of topic that could be complicating, but while we do it in the practically, we'll find the understanding of when to use array and when to use enumeration. So for now, let's keep it simple. Array enum is going to be your special reference type, and that defines set of named constant. They can represent a group of related constants as well. And then the fifth one, what we have is annotation. Annotation is also a special type. It is used to provide a metadata about the code. So mostly annotations will be not widely used in the tester's code. For example, if it is going to be uh, when there is going to be a third party library or something like that is going to be used, in that case, annotations will be used. Like for example, even when testng is used, or when BDD is used, annotations comes in. Even page object model also uses annotations. So annotation is something that would allow you to add some extra, what we'll call it as adding some metadata to your class. So that will be your annotations. So when you will define an annotation in Java, it essentially becomes a special kind of interface. So when we understand interface, we would understand the annotations better. So this is some kind of an interface. When you use an annotation, the compiler will generate an instance of that interface, meaning annotations are treated like objects in Java, making them as a reference type. When annotation is applied to a class or a method, it behaves similarly to the reference types. Annotations is stored in the class file and can be accessed at a runtime. So these are the 5 types of reference types um, that is used in Java 8. And let's see the practical uh, application of the reference types in code.